Saving your work is crucial habit when working with GNU Radio or any software really. Imagine losing your progress after all the effort you've put in. To save your flow graph, you will simply click on File in the menu bar and then choose Save or simply press Ctrl S. And here I have a folder named Typhoonix STR and let's change name to sourcing.grc and save it. And here we are. Now it is time to run the flow graph and see it in action. To execute it, I will click on the execute icon on the toolbar. It looks like a play button, but if everything is set up correctly, GNU Radio Companion will compile and run your flow graph, opening a display window with the output. But if the execution button is grayed out like this, it means there's an error in your flow graph. Look for any blocks or connections highlighted in red, like in this case. These are your culprits. Red usually indicates a missing connections or misconfigured property. Fix the UG and try running the flow graph again. That's it. When your flow graph runs successfully, a window will pop up displaying a waveform. In this case, you will see a constant waveform from the value 0. If the display window seems too small like this, you can resize it by clicking and dragging its corners like this. Once you've admired your waveform, you can close the window by clicking on the X in the upper right corner. This will also stop the flow graph from running. Take a moment to appreciate this milestone. You've just executed your first STR flow graph. Let's make things a bit more exciting. A flat line 0 isn't much to look at it. Let's modify the constant source block to produce a more interesting value. We will double click on the constant source block. And in the properties window that appears, find the constant value field and change it, let's say 3.14. A nod to our friend pi. And once it looks good, click on the apply, or you can click directly to OK to save your changes. And notice now how the constant source block in the workspace updates to reflect the new value. GNU Radio Companion automatically adjusts the block's visual representation to show its current settings. This feature is incredibly useful for quickly understanding your flow graph's configuration without diving into each block individually. Now that you've made changes, run the flow graph again by clicking the execute icon. This time, the output window will display a constant line at 3.14, but you might not see it right away. If you don't see the new line, you're probably zoomed in too much. Use your mouse wheel to scroll out until you see a second line appear in the display. The constant line at is 3.14 should be now visible. Here, you will notice another line labeled signal 2, sitting at 0. What's going on here? Welcome to the world of complex numbers. In GNU Radio, many blocks produce complex numbers, which consist of two parts, a real part and an imaginary part. Signal 1 represents the real part and signal 2 represents the imaginary part. While complex numbers might sound intimidating, they're essential in signal processing, especially for handling frequency and phase. Don't worry, we will explore them more truly later. For now, it is enough to recognize them as a core concept in GNU Radio. Stay tuned, we are just scratching the surface of what GNU Radio can do. You've seen how to get data into your flow graph with source blocks and how to get it out with sync blocks. What do you do in between? The short answer is math. We will do a little bit of multiplying here. Now we will uh, type multiply in the search bar and double click on the multiply const or drag and drop to add your workspace. Now the block multiplies the incoming signal by a constant value and outputs the result. Now right click in the line between the throttle and time sync, then select delete. Or alternatively, you can also just click on it and click delete. Now we will connect the throttle block's output to the input of multiply const. Then we will connect the output of multiply const to the input of time sync. By default, the multiply const block uses a multiplier of 1, meaning it doesn't change the signal. Let's test. Here, it's the same output. But let's modify this. We'll double click on the multiply const block. In the properties window, update the constant field to Q. And click OK to save your changes. And this block will now display the new multiplier in the workspace as shown here. Now we will click the execute button to run our updated flow graph. And here, when the display window appears, zoom out further by scrolling up with your mouse wheel. You will now see the signal line, and signal 1 will appear at double the previous value as shown here. While multiplying by 2 might seem basic, this exercise highlights a key concept in signal processing. Everything happening between your input and output is just a math. As you progress, you will explore more advanced mathematical operations and how they shape signals. Now, in conclusion, congratulations, you've built a flow graph that performs basic signal manipulation using GNU Radio Companion. At this stage, you've learned how to add and configure blocks, how to connect and reconfigure flow graph elements, and how to perform basic signal processing tasks. This is just the beginning. With this foundation, you are ready to take on more complex projects like building your first radio. Let's dive deeper into what GNU Radio can do.